Exercise 10.2 in mensuration. Okay. So a toy in the form of cone mounted on a hemisphere. Mounted means you have to place one object on another object. So a toy is in the form of a cone mounted on a hemisphere. So this is the hemisphere and this is the cone. It is placed on the cone is placed on the hemisphere. Okay. So cone placed on the a cone is placed on the hemisphere. The diameter of the base, the diameter of base of the cone, the diameter of the base of the cone is 6 centimeters, and height is 4 centimeters. Height is 4 centimeters. So determine the surface area. So if there are two objects are included in any problem, you have to calculate the lateral surface area of the one tie, lateral surface area of the another tie. Then after you have to combine those two surface area. This is the procedure for any how many number of solids are does not matter. So you have to calculate simply lateral surface area of the cone. Solids individually. Then after you have to add all the lateral surface areas. So this is the first problem. So the base of the cone is 6 centimeters and the height of the cone is 4. Whenever one object is placed on the another object, definitely the diameter of this one is equal to the diameter of the bottom one. That is the minimum rule for every sum. Mounted means you have to take 6 centimeters for cone and 6 centimeters for hemisphere also. Okay? Now calculate it. So we already know that lateral surface area of the cone formula is, so first one, cone, radius, diameter 6, so radius 3. Next, height 4. We already know that lateral surface area of the cone is pi r L. So we don't know the value of L, so you have to find out the L value. So L equal to root r square plus h square. L equal to root r square value 3 square plus h square value 4 square. L equal to 9 plus 16. So L equal to root 25. So L equal to 5. Yeah. So same problem. So you have to simply calculate lateral surface area of the cone, then lateral surface area of the hemisphere. Surface area of toy. Surface area of the toy. I can directly add these two cones lateral surface areas. Okay. So lateral surface area of cone plus lateral surface area of so lateral surface area of the cone plus lateral surface area of the hemisphere. Lateral surface area of the cone formula pi r L. Pi r L plus lateral surface area of the hemisphere 2 pi r square. Here r and r both are same. Okay. So what is the value? What are the common factor here? Pi r. So here pi r is there, L plus, so pi r to r. Pi value 22 by 7. Sorry, already he mentioned specifically pi value takes 3.14. So you have to write pi value as 3.14. What is the r value here? R value 3. What is the L value here? L value is 5 plus 2 into R value 3. So 9.42. This is 9.42 into 5 plus 2 3 is 6. 5 plus 6 11. 11 into 9.42. What is the that equal to 103.62 centimeter square. You see. So this is the simplified method. If you want to consider, first of all you have to calculate lateral surface area of the cone. Then after you have to calculate lateral surface area of the cone. Lateral surface area of the hemisphere. Then after you combine those two surface areas. This is the procedure, but I have to calculate directly. So your wish. This is the okay. Next, move on to the second problem. Next, a solid is in the form of right circular cylinder. A solid is in the form of right circular cylinder with a hemisphere at one end. Hemisphere at one end. And cone at other end. And cone at other end. This is the process. A solid is in the form of right circular cylinder. One end it has a hemisphere and other end it has a cone. It is the okay, this is the process. So the radius of the common base, I already told you, whenever cylinder is mounted on a hemisphere or cone is mounted on a cylinder, there is a common radius of 3 solids. So here the common radius is 8 centimeters. Common radius is 8 centimeters. And heights of the cylinder, height of the cylinder is 10. Height of the cylinder is 10. And height of the cone is 6. Height of the cone is 6. Okay. So what is the height of the hemisphere? Hemisphere height is always its radius is the height of the hemisphere. Okay. So let's leave it. Okay. Find the total surface area. So total surface area means total surface area. Total surface area means cover from top to bottom. Okay. So you don't calculate the total surface area of the each solid. You have to simply calculate the lateral surface area. But he asked total surface area of the given solid. Why you calculate the lateral surface area? In lateral surface area, lateral under this toy. There is the cone. Here cone does not include this side. So you have to calculate lateral surface area of the cone because it covers like this. Similarly, lateral surface area of the cylinder. Then lateral surface area of the hemisphere. It covers like this. So you have to calculate lateral surface area of the each bed and then each solid. Then after you have to combine all the solids. So first of all, find out the lateral surface area of the cone, lateral surface area of the cylinder, lateral surface area of the hemisphere. Okay. So I calculate directly. First I have to calculate the lateral surface area of the cone is pi r l, but we don't know the value of l. So I have to calculate the l initially. Second sum. Cone. Radius, cone radius. Already know that the radius of the 3 solids have same. So r value is 8 centimeters. H value is 6 centimeters. Radius is 8 centimeters and height is 6 centimeters of the cone. Okay. So we have to calculate L equal to r square plus h square. L equal to what is the r value here? 8 square. H value is 6 square. L equal to 8 square value 64. 6 square value 36. That equal to 64 plus 36 100. Root 100 value. Sir. L equal to 10 centimeters. L equal to 10 centimeters. Okay. This is all about the cone. Next, cylinder. Cylinder radius 8, height is 10. Okay, hemisphere. Radius 8. Here all radiuses are same, so all are. Here there are 2 heights. One is cone height and another one is cylinder height. So one is h1. I have to h1, h2. I have to take like this because there are differences in heights of the solids. So I have to calculate total surface area of toy. Total surface area of the toy. So lateral surface area of cone plus lateral surface area of cylinder plus lateral surface area of okay. There are three solids. So lateral surface area of the cone plus lateral surface area of the cylinder plus lateral surface area of the hemisphere. Lateral surface area of the cone formula pi r l. Lateral surface area of the cylinder 2 pi r h. So lateral surface area of the hemisphere 2 pi r square. Here what is the common of here? Here pi r, pi r, pi r. At the same time all r's are equal. All r's are equal. So I have to take pi r as the common. Pi r. So l plus 2h plus 2r. Okay. L plus 2h plus 2r. So what is the pi value here? So pi value is again pi value mentioned as 3.14. You have to take 3.14. 3.14 and r value is 8 and l value is 10. L value is 10. 2 into what is the h value? H is all about cylinder. H value cylinder is 10, not the h is sorry. Its h value is 6. 6 is of cone. Here this h belongs to cylinder. That's why you have to take cylinder. Cylinder height is 10 plus 2 into radius. What is the radius? Radius are all same purpose. 25.12. So 3.14 into 8 that equal to 25.10 plus 20 plus 2 into 8 16. Okay. 25.12 into 12 10 plus 20 plus 16. Sorry 46. 115. So 25.12 into 46 that equals to 115. Okay. 1155.5 centimeter square. This is all about the lateral surface. So he asks so total surface area of the toy, but you have to calculate lateral surface area of the each toy. So if there is a single solid, he asks to find the total surface area. You have to calculate total surface area. Okay. A medicine capsule is in the shape of a cylinder. Medicine capsule is always in the shape of cylinder with two hemispheres are stuck with ends. Two hemispheres. Okay, these are already know that there is a capsule. It is in the form of like this, and the middle part is like a cylinder, and the ends are in hemisphere format. So find its surface area. Surface area. What type of surface area? He does not mention any total surface area or lateral surface area. So you have to calculate lateral surface area. Simply. Okay. We need surface area. So that's why we have to calculate lateral surface area of the each solid. Lateral surface area of the hemisphere, lateral surface area of the cylinder, lateral surface area of the hemisphere. Here both hemispheres have same radius. So both the hemispheres have same lateral surface area. Okay. Okay. Immediately, okay. The length of the capsule. The length of the capsule is 14 mm, and its width is 5 mm. Okay. Find its surface area. You have to understand one thing. Here capsule length is 14 mm, but we don't know the height of the cylinder. So first we have to find out the height of the cylinder. How can we calculate the height of the cylinder? We already know that in every hemisphere, what is the height of the hemisphere? Height. What is the height of the hemisphere? Height of the hemisphere is always the radius, because if you consider a circle, the height of the circle is 10. Height of the circle is 10. Okay. Height of the circle is 10 obviously. If you cut this one, so now the height of the circle is now the height of the hemisphere is 5. So in every sphere the height is its diameter. In every hemisphere the height is its radius is the height. Okay, that is the main reason. Okay, so now the length of the hemisphere is 5. Now again here also the length of the hemisphere is 5. So 5 plus 5. Sorry. Here 5 millimeters is the diameter. Sorry. 5 millimeters is the diameter of this particular capsule. So the height is its radius, that equals to 2.5. In the similar way, it is also 2.5. Okay, 2.5, 2.5. 2.5 plus 2.5, 5. So 14 minus 5, 9. So the height of this one is 9. So the height of the cylinder is 9. The height of the radius of the cylinder is 2.5. The radius of the cylinder is 2.5 because 5 mm is the diameter here. So you simply calculate the lateral surface area of the hemisphere plus lateral surface area of the cylinder plus lateral surface area of the hemisphere. So height cylinder, height is 9, radius 5 by 2, that equals to 2.5. Okay. Hemisphere, radius is equal to 5 by 2, that equals to 2.5. Okay. Cylinder, each value is 9, radius 2.5, radius 2.5. Okay, now total surface area of the capsule. So lateral surface area of cylinder plus here there are two hemispheres. Two hemispheres have same lateral surface area. I have to write like this: 2 into lateral surface area of hemisphere. Okay, 2 into hemisphere. Okay, lateral surface area of the cylinder formula 2 by RH. Lateral surface area 2 into lateral surface area of this hemisphere 2 into 2 by r square. What are the common factor here? Again 2 by r. Here 2 is there, 2 is there. Pi r. You have to 2 by r into h plus 2 r. Okay. What is the pi value here? Pi value 22 by 7. 2 into pi value 22 by 7. And radius, we already know that radius of this one is 2.5. 2.5 can be written as 25 by 10. 3.5 can be written as 35 by 10. 3.56 can be written as 356 by 100. After point there are two decimals only. Now 2.5 can be written as 25 by 10. Okay, that equals to 25 by 10 into h. H is about cylinder. Cylinder height is 9. 9 plus 2 into and r value. R value is 2.5. Okay. 2.5. So there is no cancel. 2 in 10, 5 times, 5 in 25, 5 times. 22 5 is 110 by 7 into 2 into 2.5. 2.5, 5. 5 plus 9, 14. Okay. 7 in 14, 2 times. 110 into 2, 220 centimeter square. 220 centimeter square. Okay. This is all about the lateral surface area of the capsule. There is no, you have to calculate the height of the cylinder. That is the crucial point. So we already know that the radius of the hemisphere is the height of the cylinder. Height of the hemisphere. So what is the diameter here? Diameter is 5. Radius is 2.5. 2.5 is the height of the particular hemisphere. Here is also 2.5. So 2.5, 2.5, 14 minus 5, 9. So that's why 9 becomes. So this is our simplification process. Okay? Next, fourth one. 2 cubes, each of volume 64 centimeters. 2 cubes. Two cubes, each of volume 64 centimeters. Volume of each cube is 64. Volume of cube formula is A cube. A cube equal to 64. A cube equal to 64 can be written as 4 cube. So A value is 4. A value is 4 centimeters. Now are joined end to end together. Suppose it is a cube. Now you have to join another cube. So let us take it is also a cube. So it is joined with that. Okay. Now it becomes like this. So what is the shape of this one? This is the shape of the cuboid. Whenever so if you cut two solids and join, those two solids are like cubes. Whenever you join those two solids, then it becomes a cuboid. Okay. So A value 4 centimeters. So this is also 4 centimeters. So this is one cube and this is one cube. Each side cube is 4 centimeters, 4 centimeters, 4 centimeters, 4 centimeters, 4 centimeters. Okay. Now whenever after completion of the joining, the solid is like this. Okay. Here it is 4 centimeters, 4 centimeters. Total 8 centimeters. Find the total surface area of the resulting solid. Total surface area of what is the solid here after joining the two cubes? The solid is in the form of cuboid. So total surface area of cuboid equal to formula 2 into LB plus DH plus HL. So 2 into what is the length here? Length converts into total length is 8. So L value 8. What is the breadth value here? Breadth value does not change whenever we join side by side. So breadth value is 4 centimeters. Breadth value is 4. If the height changes, height is also not changing. So height is also 4 plus 4. What is the length value here? 8. 2 into 32. 4 4 is 16. 4 8 is 32. So 32 plus 16, 48. 48 plus 32, 80. So 280 is 160 centimeter square. This is the total surface area of the cuboid. Okay. So you have to first you have to find out the value of side of the cube. Based on we already told that the volume of the each cube is 64. Volume of each cube is 64. So what is the volume here? 64. Okay. Then after the only difference between the cube and the cuboid is its length in this sum. Okay. Next move on to the fifth sum. A storage tank consists of a circular cylinder with hemisphere stuck on either side. A storage tank. This is the storage tank is stuck with hemisphere on both sides. This side is also hemisphere and this side is also hemisphere. If the external diameter of the cylinder an external storage consists of a circular cylinder with hemisphere stuck on either side. If the external diameter of the cylinder is 1.4 meters, external diameter is 1.4 meters and its length will be 8 meters. Its length means cylinder length. Its length is 8 meters. Find the cost of painting it on the outside of the rail. Outside. So you have to calculate the lateral surface area of the cylinder, lateral surface area of the hemisphere, lateral surface area of the hemisphere. Now you have to combine all the solids of the lateral surface areas. Then after you have to get the value how much you cover the with the paint. Okay. So first one. Directly. Here the radius of cylinder and hemisphere both are 1.4. The height of the cylinder is 8. Okay. Cylinder radius 0.7. 1.4 by 2 that equal to 0.1.4 by 2. 2 that equals to 2 7 is 14. So 0.7. So this is the radius. Height is 8. Height is 8 meters. Hemisphere radius is same like this. So it is also 0.7 centimeters. Okay, you have to calculate the total surface area. Total surface area means here there are 3 solids, 2 hemispheres and 1 cylinder. So you have to calculate lateral surface area of each one. Then after you have to add 3 lateral surface areas. Then after you become the total surface area of the particular tank. Total surface area of tank. That equal to lateral surface area of cylinder plus lateral surface area of cylinder plus how many hemispheres are there? 2. So 2 into the 2 hemispheres have the same lateral surface area. That's why I have to calculate 1 and multiply with 2. Then we get 2 lateral surface area of the hemisphere. Lateral surface area of hemisphere. So lateral surface area of the cylinder formula 2 by r. 2 into lateral surface area of the hemisphere 2 by r square. Okay. What is the common factor here? 2 by r, 2 by r. 2 by r. H plus 2 r. Okay. 2 into pi value. What is the pi value here? Pi value we didn't mention anything. So I have to take pi value is 22 by 7. What is the radius here? Radius is 0.7. 0.7 can be written as 7 by 10. H. Again H is height of the cylinder. H is 8. 8 plus 2 into 2 into 0.7. 2 into 0.7. I didn't write 0.7 as 7 by 2 because after in the next step we have to go through the LCM. That's why I have to simply write directly 0.7. Here I have to write 7 by 10 because here 7 is cancelled. So based on our calculation purpose, I have to write like this. Okay. So if you have to write 0.7 as 7 by 2, sorry 7 by 10 and 2 in 10 5 times. Then after we have to do LCM. The same part. Simplification is what we want. 7 cancel. 2 in 10 5 times. So 22 by 5. So 2 into 0.7 1.4. 1.4 plus 8 9.4. 9.4. 206.8 by 5. This is the lateral surface area. So here the cost of painting it outside is 20 rupees per meter square. Sorry, these are all meters. Sorry. Okay. The cost of painting is 20 rupees per meter square. Here how many meter squares are there? 206.8 divided by 5 meter squares are there. So now the cost of painting is 206.8 by 5 into 20. That equals to 827.2. Okay. This is the cost of the tank. Okay. First we have to simply all problems are on lateral surface area only. So you have to calculate lateral surface area, then you add those. So next two sums are some logical. So a hemisphere is cut from one face of a cubical wall. A hemisphere is cut from one face of a cubical box. A hemisphere is cut like this. So, a hemisphere is cut from this side. So the diameter of hemisphere is equal to the length of the cube. Obviously, whenever you cut like this, you scoop it like this. The diameter of the hemisphere is equal to the length of the cube. So here, hemisphere starts from here. From here to here, it is diameter. So this diameter is equal to the length of the cube. Let the diameter of the cube be A. Let the length of the cube be A. So the diameter of the cube is also A. Okay. Then after, determine the surface area of the remaining solid. So you have to cut the hemisphere at one side of this cube. So like scooping. In ice creams you already see it in scooping. So there are 5 faces. 5 faces are still remain constant. So there is no changes in those 5 faces. But in the 6th phase, you have to scoop the hemisphere. So what is the face of the one face? It is in the shape of square. So what is the area of the square here? Area of the square is A square. So area of 5 faces. Area of 5 faces. So from this side I have to cut the hemisphere. In the 5 sides all are in the shape of squares. Area of each side is in the form of square. Area of the square formula is A square. Okay. So there are how many faces are there remaining? 5 faces. So 5 A square. Okay. One face is A square. So remaining. So this is important now. I have to scoop it like this. Okay. So I have to take hemisphere like this. Hemisphere. Okay. This one. I have. So this is the surface left here. Okay. Next one. So first of all, there is a shape of hemisphere. So you have to calculate lateral surface area of the hemisphere. Lateral surface area of hemisphere. Lateral surface area of the hemisphere formula is 2 by r square. What is the radius here? Diameter is A. So radius is A by 2. 2 by A by 2 whole square. That equal to 2 by A square by 4. So 2 into that equals to pi A square by 2. Okay. This is the lateral surface area. So you have to calculate this surface area. So remaining. So now you have to calculate. This is the another surface. This is the another surface area. How can you calculate these corners area? You simply calculate area of the square minus area of the circle. Area of 4 corners. area of circle minus area of square, area of square minus area of circle. Okay, area of square minus area of the square. So whenever you have to take like this, you have to take like this. So whenever you have to take some spoon, the shape of this face is like this. So you need, there are 4 corners. So area of square we already know that area of the square is a square. So a square minus area of circle formula pi r square. Pi r square. So a square minus pi value pi, and what is the r value here? R value is a by 2. A by 2 whole square. A square minus pi a square by 4. Okay. A square minus pi a square 2 square value 4. What is the common value here? A square. A square plus a square minus so this is the surface area of the 4 corners. Now we have to calculate the total surface area of this solid. So now you have to add this one and also corner side also. Okay. Area of solid. So you have to add all the area of 5 faces plus area of the hemisphere, lateral surface area of the hemisphere plus area of the 4 corners. So 5a square plus pi a square by 2 plus a square minus pi a square by 4. 5a square plus a square 6a square. Okay. Pi a square plus pi a square by 2 pi a square by 2 minus pi a square by 2 6a square. What is the LCM here? 4 is the LCM. 2 into 4 2 times 2 pi a square minus 4 into 4 1 time pi a square. So 6a square plus 2 pi a square minus pi a square 1 pi a square pi a square by 4. So what is the common factor here? A square. So a square that is equal to 6 plus pi by 4. A square into 6 plus pi by 4. This is the problem. You have observed carefully whenever you have to cut from one side of the square, it is in the shape of the hemisphere. So there are 4 corners left. You already know that. But maybe you have a formula. You have a doubt. How can you add by cutting the? Okay. How can you add pi a square by 2 the total surface area whenever we cut it? Because it is the surface area. Whenever you have to paint, that curved hemisphere. Curved surface area of the hemisphere also. Okay, that's why I have to add, because the surface area means whether you have to cut, there is a shape in that cube. So you have to add the surface area of the hemisphere also. Okay, last and final step. A wooden article was made scooping from each of the solid hemisphere. In the previous sum, scooping from the cube. In this sum, you have to scooping from the cylinder. You have to scooping from the cylinder. Okay. shape like this, scale like that. Now, if the height of the cylinder is 10 centimeters, height of the cylinder is 10, and the base radius, what is the radius here? Radius is 3.5 centimeters. Radius is 3.10 centimeters, 3.5 centimeters. Find the total surface area of the given solid. Here you have to scoop from this one, you have to scoop from this one, this side also. So there is a this lateral surface area. You have to find out the lateral surface area of the cylinder, then after lateral surface area of the hemisphere, lateral surface area of the hemisphere, then after lateral surface area of the hemisphere. Okay? Lateral surface area of cylinder, radius 3.5, height is also 10. Hemisphere, radius 3.5. So simply you have to add all the lateral surface area. Don't bother whenever I have to scoop the hemisphere from this side. Then why can I add the lateral surface area of the hemisphere? You have to scoop from this side also. But the shape of the scooping is like hemisphere. Whenever you have to paint this surface area, you have to paint also the lateral surface area of the hemisphere also. It is in the shape of curved surface area of the hemisphere. So you have to paint that one also. That's why I have to add, because I have to calculate the lateral surface area of the hemisphere. So total surface area of solid. So lateral surface area of cylinder plus how many hemispheres are there? 2. So 2 into lateral surface area of hemispheres. Okay. Lateral surface area of the cylinder plus 2 into lateral surface area of the hemisphere. So lateral surface area of the cylinder formula 2 by RH. So 2 into lateral surface area of the hemisphere 2 by r square. What is the common value here? 2 pi r, 2 pi r, 2 pi r. Here the remaining one is h. Here h into 2r. 2 into pi value 22 by 7. Radius. What is the radius here? Radius is 3.5. 3.5 can be written as 35 by 10. 35 by 10. H. What is the H value? H is all about cylinder. Cylinder height is 10. 10 plus 2 into R. What is the R value here? R value is 3.5. 2 into 3.5. Okay? 7 in 5, 10 times, 5 in 10, 2 times, 2 into cancel. So, 7 5 is 35, 5 in 10, 2 times 2. So, there is 22 plus, into 22 into 2 into 3.5, 2 3.5, 7. 7 plus 10. 22 into 70, that equals to 374 centimeters square. Okay.